Hello. In this video, I'm going to introduce you to data tables. Data tables are a way of doing sensitivity analysis to know and understand how our model changes when the inputs to our model change along with it. So we're going to really see how input changes drive changes in the outcomes that we're interested in. So data tables are a nice way to do this quickly and efficiently. So before I get to data tables, let's just set up the model that we're looking at as an example. In this model, we're looking at a retirement savings example. Right? The idea is that you open a retirement savings today, you fund your initial account with $5,000. You're then going to save for 40 years. You're going to make equal, basically, payments to your account, right? You're saving a certain amount each year. And then finally, at year 40, you're going to retire and withdraw that money over the next 30 years. Along the way, you're going to expect a big bonus one year from your job. You're also going to take a big vacation. And ultimately, you're also going to think about funding a donation when you pass on. So these are all different elements of your retirement plan. So you want to be able to fund your retirement plan by saving enough today. So the question is, how much do you have to save every year for the next 40 years to be able to take that vacation you want to, make a big donation to the U of A, and then also have $100,000 a year to live on for 30 years in retirement? So that's what this model is designed to answer. So importantly, you notice we lay out a lot of assumptions here. The interest rate, or the amount that you're going to earn on your savings, is set at 4%. We have an initial deposit of $5,000, how much you save. You're going to get that $50,000 bonus in 25 years, a $20,000 vacation in 12 years, 40 years of savings for retirement, $100,000 per year to spend in retirement for 30 years, and then $1 million donation in 70 years. So that's the basic structure of the model. Essentially, the way we solve this model, the solution strategy, is to get the present value of all the inflows and all the outflows in today's term, and then realize that the inflows must equal the outflows, right? We have to have an NPV neutral problem here where you're saving just enough to fund all the outflows that you need in retirement. So just quickly kind of describing the solution, let me zoom out so you can see a little bit more. The annual savings amount, that's our question mark, what we want to solve for. Well, we know the present value of the initial deposit is $5,000. We can discount that bonus back to today's dollars. That's about $18,000. The vacation is about $12,000 of an outflow in today's dollars. Now, how much do we need at retirement? At retirement, you're going to need $1.7 million when retirement starts. That'll fund the $100,000 a year for 30 years. What is that in today's dollars? Well, back that up 40 years. That means you would need $360,000 today to finance that future retirement spending. And then finally, that $1 million donation, well, it's in 70 years. So to donate $1 million in 70 years, you would need $64,000 today. So once you add up all those pieces, you see that we're short $436,000. So if you were to inherit $436,000, then your retirement plan's are covered. You're set. If you don't have inheritance, though, you're going to have to save every year. And so we can use an annuity calculation to determine that we would need to save $20,872 to make that work. All right? Oh, I'm sorry. So you see here the outflows are $436,000. We do have a couple inflows to counteract that, though, right? We have the initial savings we put in, as well as that bonus we expect to get. Once we net those out, we need $413,000 in today's dollars. And so to get that, we can save $20,872 a year for 40 years to give us that amount. All right, so that's our model. Now we want to think about, all right, maybe that $20,000 seems a little aggressive. Maybe that's more than I want to save. Now, what happens when we start changing the model's parameters? And can we understand how, for example, the interest rate would affect how much I need to save? So one way we can do that is just do it manually. We could come in here and say, all right, well, we know at 4%, 20,000 is our answer. And I'm going to come over here and put that in my table. I'm going to just go ahead and paste the value there. I can now change my model. Let's make this 2% and see how much I need to save. We'll go into the bottom. I see my model updated. Now I need to save $45,000. Let's go ahead and paste values to save that value right there. If I want to finish my table now, I can do 3%, I'm just going to come down here and copy paste my values over. I can do 5%, and you can start to see that this gets a little bit laborious and that we'd like to have an easier way to basically do all this copying and pasting, right? If we get to a situation where you're doing a lot of copying and pasting, odds are there's going to be a better way. And so once I finish this last one, we'll look at what that better way is. And it's ultimately going to be data tables, which is what this video is about. All right, so I just went through, basically typed this 2, 3, 4, 5, and 6% numbers into our input, and then I copy and pasted each of the resulting values. So what we can see is that if interest rates are only 2%, I got to save $45,000 a year. If interest rates are 6%, now I have to save $9,000 a year, quite a bit better. So the interest rate really matters for how much you need to save to fund your retirement. Again, this is less about retirement and more about how we do data tables in Excel. So let's set this up to do this quickly and efficiently in a data table. So I'm going to set it up down here. I'm going to make one really important change. I'm going to slide my input parameters down. The 2, 3, 4, 5, and 6, we slide down. And now at the top of my data table, and how we construct this is very important, I'm going to link my answer cell. All right, so at the top here, I have the answer cell to indicate that this is a linked cell that's not, an important calculation of my model. I'm going to go ahead and just gray it a little bit. All right, that just indicates to any user that it's a little bit different cell. You can check out what's going on. So now what I have is I have my inputs in the left column. At the top of the second column then, I have the value that I want to record. Remember this outcome of my model is what I was recording and copying and pasting up here in these cells. So I put that value at the top of my data table. I'm then going to select this entire range of cells, go into data. Underneath the what if analysis is data table. All right, so in the data table now, notice it has a row input cell and a column input cell. This is going to be for a two-way data table. So you can actually vary two different inputs at the same time and see how that affects your answer. In this case, we're going to start with a one-way data table. So we're only going to use one, and we're going to use what's in the column. All right, we're going to pick the column input cell because our inputs are located in the column. All right, 2, 3, 4, 5, and 6% are all in a column. So our column input cell. Now what we have to let Excel know is where we should put those different input amounts. So where we want them in our model is this cell C5, because C5 is where our interest rate input is to the model. So we're going to go ahead and click OK. And right away we see that nothing changed. Right? We have the same value every year. All right, this happens with a lot of your data tables. And the reason has to do with your calculation options. So real quick, we're going to go up here into formulas. On the far right side, we see calculation options. All right, notice that I have three options here. I have automatic accept data tables, and manual. If it's manual, you have to basically force Excel to calculate anything whenever you want it to calculate. Automatic means that everything calculates every time anything changes. All right, it can be a little bit more taxing on your system and require a lot more calculations than you might need. Automatic accept data tables means that anything except a data table gets automatically calculated. The thing with data tables is it requires calculations to iterate many, many times, and you'll see why in a second. And as a result, I use this automatic except for data tables option. If that's the case, what you can do is you can hit this calculate now button. Notice that the shortcut key is F9, and that will calculate your spreadsheet. So I'm going to go ahead and hit F9, and now notice that my data table updated. And all 5 of those values updated to what we had done before. Because all Excel did was step by step take the 2%, type it up here in the interest rate, copy and paste the value. Take 3%, type it in our input, take the answer, copy and paste it in our data table. That's effectively what Excel is doing. The same exercise I went through at the beginning of this video, Excel is doing through the data table. It's just doing it for you much more quickly than we can do on our own. So that's the idea of how we can use a data table to do a quick sensitivity analysis. The next couple of videos will show you how to do this, a one-way data table, either vertically like this or also horizontally, and then also show you how to do a two-way data table.